Homework 1.7, Inequalities, Video 6. Homework due Saturday, May 16, 2020 at 11:59 p.m. All right, let's take a look at another polynomial inequality. And I think I neglected to mention in the previous video that you should be looking at questions 8, 9, 10, and 11 in Homework 1.7 as they are polynomial inequalities. All right, solve 2 times open parentheses x squared plus 6 close parentheses is less than 11x. And you may recall from the Quadratic Equation video series that we saw that inequality more than once. But that's okay. Excuse me, we saw that as an equation more than once, but that's okay. I like recycling problems. And I still have the procedure for how to solve any inequality. Step 1, change to equal and solve. Step 2, partition the number line at those solutions. Step 3, select one test value from each interval. Step 4, test each value in the original inequality. And step 5, if a test value makes the inequality true, its interval is part of the solution. So if we're going to solve this, the first thing we should do is pretend it says equals. So let's change it to an equation. Oh, word of warning. The approach that I'm showing you is similar to the author's approach in the book, but it's a little bit different, but they get the same results. The approach that they show you in the book is more specific for polynomials, but the approach that I'm showing you will work for any inequality. So if you click show an example or help me solve this in the homework, it's going to show you something a little different. I promise you it's equivalent, but you've been warned. Okay. So if we're going to solve this equation, it's a quadratic equation, so we'll want to get it equal to 0, but not until we get rid of the parentheses. So we have 2x squared plus 12 is equal to 11x. And because it's a quadratic equation, we're probably going to want to get it equal to 0. Let's move the 11x over to the left side. Belongs in the middle, so we have the powers in order from highest to lowest. And the 11x will change signs since it's changing sides. So 2x squared minus 11x plus 12 is equal to 0. Now, it is your decision on whether or not to use the quadratic formula or a different approach. I'm going to factor this because A, I know it factors, and B, if something factors, I'll get the solutions faster than the quadratic formula. I believe, if I recall correctly, that this factored into 2x minus 3 and x minus 4. A real quick FOIL will show me that it is correct. So if we set each factor equal to 0, 2x minus 3 is equal to 0 and x minus 4 is equal to 0, then we can just solve each of those. Our first solution is 3/2, and our second solution is 4. Well, when I say solution, I mean solution to the equation. But we're in the midst of solving an inequality, and everything we've just done is step 1 in how to solve the inequality. What do we do with the solutions we just found? We use them to partition the number line. As a verb, partition basically means to cut into pieces such that all the pieces together recreate the entire whole. So in this case, we're going to partition the number line. But we have a small obstacle to overcome. We have 2 values at which to partition, but we got to make sure they're in the correct order. So which number should go to the left, 3/2 or 4? Which number is less? Well, for comparison purposes, it's easier to think of 3/2 as 1.5, which is clearly less than 4. So 3/2 and 4. Then, from each interval, we pick a test value. So, I need to pick a value to the left of 3/2 or to the left of 1.5. How about 1? I got a better idea. I can pick any number less than 1.5. How about 0? That's an easy number to work with. Unless 0 is a partition value, it will belong to one of the intervals. Now I need to pick a test value between 3/2 and 4. In other words, a number between 1.5 and 4. How about 2? No need to get fancy. And something to the right of 4. How about 5? And remember, these are called test values because we test them in the original inequality. So each one of these is going to go all the way back up here. Let's start with the 0. 2 times 0 squared plus 6 is less than 11 times 0. Well, the right side of this is just 0. The left side in the parentheses is equal to 6. 2 times 6 is 12. 12 is less than 0. No, it's not. That's false. That means we do not want the interval that the 0 came from. Let's check x equals 5, and then I'll slide down here and check x equals 2. If we check x equals 5, we get 2 times parentheses 5 squared plus 6 close parentheses is less than 11 times 5. Well, 11 times 5 is 55, but what's the mess on the left side equal? 5 squared is 25. 25 plus 6 is 31, and then 31 times 2 is 62. So the left side is 62. 62 is less than 55. It's also false. We don't want that interval. Wait a minute, what if we throw away the one in the middle also? Then there would be no solution. So let's check the one in the middle, and I'm going to change colors just for a little bit of readability purposes, and I'll have to slide it down some. So if we check x equals 2, we have 2 times the quantity 2 squared plus 6 is less than 11 times 2. Well, 11 times 2 is 22, so not a lot to look at there. 2 squared is 4. 4 plus 6 is 10. 2 times 10 is 20. 20 is less than 22. It's true. I have seen problems where you dismiss every interval and there was no solution. I have seen problems where you keep every interval and the solution is all real numbers. So keep that in mind as you're doing these. So the only interval we want is the one that the 2 came from, so that would be this interval. Now, are we going to use parentheses or brackets? Less than means we use parentheses. So the only interval we want is the one in the middle, and the interval in the middle goes from 3/2 to 4. Again, if you click view an example or help me solve this on 8, 9, 10, or 11, they will show you a technique that is analogous to this, but will look a little bit different. The only reason I'm not showing you that technique is because it would not work for the type of problem I'm about to show you next. This technique will work for practically any inequality. There's a few weird exceptions way down the road that you won't run into. So I like to show you the technique that always gets the job done. All right, 1 or 2 more videos and we're done.